So guys, so for our calculus project, we decided we're going to do differential equation on terminal velocity. It's a physics concept, but because it's a differential equation, it's calculus. Right? So a little overview on what terminal velocity is going back to physics. So say this is your object. In this case, it's a ball. Okay? And there's the force of gravity going down, and then there's this K constant, and there's air resistance, KB, how fast the wind is going, and that's up, slowing the ball down. So what terminal velocity is the object is traveling, and it reaches a point where its motion cannot exceed a certain speed, okay? And that's its terminal velocity. At this point, its acceleration is 0. That's why this is asymptotic, okay? And we already know what m is. M is mass, g is gravity constant. So let's take you through exactly how you get to solving the difference. First of all, you have to start out with a few of these here I'm looking for givens. This is what starts the problem. First of all, we've all taken physics, so we all know acceleration equals F net over the mass. Right? So in this case, we're taking these two forces that are acting on the object, plugging them in for F over the M. So we get mg minus kb, because the force of gravity is obviously more significant because the object is traveling down. So then we multiply out, do all the algebra. Next big step is we convert this A to dv dt, because it's a diffie, so we want to try and make sure we have the same variables and its derivatives. Next, we're going to, we know that in a terminal velocity equation, A is going to equal 0 eventually. When that happens, the velocity of the object is terminal velocity, which means mg is equal to kbt. Because if you plug in 0 for A, right, blah, 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 you do all that algebra. So you get that terminal velocity is going to equal mg over k. And this is when vi is this, vf is unknown, ti is 0. Okay? So divide out that k, and now you have an equation that looks like m over k times the derivative of velocity equals mg over k minus v. Next, we're just going to integrate that. That's how you're going to get your equation. So now we get km over t. Km over t, because we separated, and this, I skipped a step. We separated the variables, so we got dv over to this side, and we got dt over here by itself. Okay? That's, again, algebra. Calculus now. The integrating part. So this goes to kmt, right? dt just goes to t, right? And here, it goes to ln of mg over k minus v, plus a constant, obviously. So, our given constraints is at t equals 0. Okay? So we want to try and find out what's going on at t equals 0. So we know that at t equals 0, the velocity is 0. We can look at this graph and tell that. Alright? So plug this in, we do all the algebra again, and we get that c equals the natural log of mass times gravity over the k constant, which is the air resistance. Come back up top. Right? Now we just switch. We had this negative. We just multiplied by -1. Make this nice and even. We just combine terms. So now we have negative km, negative k over m t is equal to the natural log of mg over k minus v over mg over k. So now, to get this into a nicer equation, we want to eliminate this ln, this natural log. So we're just going to raise it. We're going to raise both sides by e. So this side goes to e to the negative k over m times t. This side, just the natural log goes away. So now this side is left with mg over k minus v over mg over k. We're going to multiply both sides so that we can get rid of this mg over k. now we're left with this. Bam! Right here. This nice equation. And if we simplify even more, there it is again. And now we are going to do some reworking, so we get v on the side by itself. So that comes out to this, right? And we know we already plugged in c up here, right? Don't forget about that. Important. So now we're here, and now we just do some factoring out, and we know that mg over k back over here equals vt. So we can say that the terminal velocity, okay, is that, right? And so we can say the velocity as a function of time is the terminal velocity times 1 minus e to the negative k over m times t. So basically, if you want to try and solve for velocity, you need to know the air resistance constant, you need to know the mass, and you want to find out at what time, and you want to know velocity, and that's it. That's the brakes, and then you get this nice graph of this, and if you want to take it a step further, you can derive this equation. It's not going to come out nice, it's going to come out really nasty, because you're going to have to derive it with respect to t, and then you get acceleration. But what's the point of acceleration when? Terminal velocity. That's all. Mark's doing a demonstration. That's our project. Go for it. So, Mark has accomplished the impossible. Ball in the cup from the top of the 3rd floor, right outside our beautiful math class. How's this terminal velocity? Well, the ball had a constant speed on the way down. Right? We'll calculate in a second. So, Mark, I give you the honors.
Cheers.